So I think we're at a point in the curriculum where it pays to revisit the four IVMs, maybe not directly, but you see there's C60 there. This is familiar territory, but maybe you've joined us recently. A quick review would be good, and it's a chance to use my volume 3 cube made of mites, 24 of them. What's a mite look like again? It's just a very simple 3 right triangles tetrahedron, and it fills space all by itself. Doesn't need any help from anybody else except right now. Oh, there we go. I got it back together. Rectangular cross section. Spam it together, and there we go. A cube. Now we say volume 3. You can make it your whatever volume you want. And then here's the thing. The things that poke in, we call them half couplers, but there's 6 of these, right? Because it's a hexahedron. So 6 of these half oblate octahedrons poke inwards, and if you reflect them to just poke outward, right? It's the same exact shape. It's just pointing out the other way. And since there are 6 faces for this cube, we just need to get these half couplers, these half oblate octahedrons, right? And get my hair out of the model. And what you can probably see we're doing is we are creating the octahedron that is the dual of the cube. How did we do that? Well, the long diagonals, you could say. Actually, what we're really doing, do I have all the faces added? No, the octahedron is there by implication as the long diagonals of the rhombic dodecahedron. So this is the famous rhombic dodecahedron. And what we're doing with C60 is we're keeping these domains. We're saying, yes, we have a CCP, we have an FCC, an IVM made of rhombic dodecahedra. But if we think about the ball that is kept inside the cube, right, just a smaller radius ball. So there's still a ball everywhere that there is a rhombic dodecahedron center. So that's the same. But now we shrink the ball so that it's tangent to the inner cube, right? And this gives us that added ability to run rails in XYZ directions when we're doing C60, right? So this is the old Genesis story of how the octahedron and the cube, which are duals of each other, managed to beget, right? Managed to give birth to their combination, which is, again, it's quite heavy when I do this because it's all magnetized and everything. So here you would see a sphere actually touching another sphere at every diamond center, right? So there would be a ball at the center of this thing, but it would be big enough to actually touch every diamond face and thereby communicate with 12 neighbors, right? And that's what the rhombic dodecahedron is. It's the domain of a CCP sphere. But if you slide off these tips, these half couplers, and think in terms of a smaller cube inside, which is always going to be there, then that is another domain, you could say, for a smaller sphere. And then we can use a kind of a lattice works to hold these in place. And you can imagine icosahedra here as well. So just wanted to do that little meditation, kind of a guided hypertune, not really an animation clearly. And animation's on the way, we'd hope. We'll see. Talk to you soon.